Today's video lecture will be talking about Fortran variables and library functions. This is a continuation to the earlier lectures. Hope you have gone through them. Also, I have posted some materials on Fortran variables in your Google Classroom and Moodle Classroom. Hope you have gone through them. It's just a short video lecture to discuss on the topics that were there in that material, which deals with Fortran variables and library functions. What are these Fortran variables? These are nothing but the names of memory locations for storing data. When we do programming, we are basically trying to solve a particular problem. In the process, we have to deal with different types of data. Data in the sense, simple example, if I want to add two numbers, I have to supply the numbers to the compiler or to the computer. The computer will store the numbers. Where it will store in its memory. So if we have to retrieve the numbers that we have supplied to the computer, we need to identify the memory location where these numbers has been stored. So the necessity for naming the memory locations. So these names itself are called Fortran variables. Say I need to write a program to add two numbers, 1 and 2. So the first number will be stored in a memory location. I can name it as A. I'll call it A. The second B. And the sum will be stored in a memory location which I'll name as C. So in the program it will be basically input the numbers A and B, then do the operation C is equal to A plus of B. So when the compiler sees this operation C is equal to A plus of B, it will look for the number A which is stored in the memory location A, named as A, and also it will take the number which is stored in the memory location named B, add both of them and store it in the memory location named as C. So it is stored forever. If we don't overwrite it, the data is stored in the memory location. So this data that we are talking about are nothing but the Fortran constants that we discussed in the earlier lecture. And we have different kinds of data or different kinds of Fortran constants. It can be numeric, it can be characters, it can be in the complex form, it can be logical data. Numeric data can be integer without the decimal point or real with the decimal point. So this simply means we have to deal with different types of data. So the location where these data are stored has to be named accordingly. Means if I name a memory location to store an integer kind of a data, I can't use the same memory location to store a real kind of a data. Simple example, say you have containers. One container you name it as sugar to store sugar and another salt to store salt. So when you get some sugar, you will put it in the container which has been named sugar to store sugar. You can't put it into the container which has salt in it. It's a very crude example, but that is how it works. In computer also, in Fortran programming, if I have named the memory location for storing integer, it can store only integers. Therefore, as because we have different kinds of data, the variables also needs to be classified according to the data they store. So what are the rules for naming variables? So what are the rules for naming the memory locations? And these rules that we are talking about are for Fortran 7.7. For different variants of Fortran, slight differences might be there. So what are the rules for naming variables in Fortran 7.7? The variable name should be 1 to 6 characters in length. I can name a memory location sugar, S-U-G-A-R. Character, how many characters are there? S-U-G-A-R, 5. So it has to be 1 to 6 characters in length. I can write it as sugar 1 also. Or I can name a memory location as number, N-U-M-B-E-R, 6. Not more than that. The first character in the variable name must be an alphabet, and the successive characters can be numeric or alphabet. So I can have something like SUM, sum 1, sum 2, but I can't have something like 1 sum and 2 sum. Why? Because the first character in the variable has to be an alphabet. No special characters are allowed. Special characters means those characters or symbols which have some special meaning in Fortran. I can't put sum plus. Plus has a specific meaning. I can't put something like add or number slash, because slash has a specific meaning. It denotes the operation of division. So these special characters or star symbol, star denotes multiplication. So these characters are not allowed in a variable name. We discussed Fortran characters, if you remember, the list of characters in Fortran. So those special characters are not allowed in naming a variable name. Fortran verbs having special meaning are not allowed. For example, later we'll talk about it, library functions. Sign. Sign is a special function in Fortran which evaluates the sign of the number, or ABS, absolute, or for that matter something like EXP, exponential. These are Fortran verbs which have special meaning, used for specific purposes. You can't use them as the names of variable, that is, names of memory location. The compiler will show an error. Presently, you just need to remember all this, go through it, learn them. So when we actually start writing programs, probably from the next video lecture, we'll be dealing with Fortran statements and writing programs. Then we can try out all these. Even now, with simple programs using the online compiler that I was talking about, you can try it out. So how are these Fortran variables classified? So as we discussed earlier, memory locations for storing different types of data needs to be named differently. So Fortran variables are therefore classified as integer variables. This is the broad classification. One by one we'll talk about it. Broad classification: integer variables, real variables, character variables, logical variables, complex variables, subscripted variables, and double precision variables. So we'll talk about them one by one. So sometimes in your exams, question might come. What are Fortran variables? What are its types? Discuss with examples. So what are Fortran variables? Already we have talked about it. What are its types? These are the types. 1, 2, 3, 4, 5, 6, 7. Basically, 7 types of variables. What are these? We'll look into it one by one. So what are integer variables? Integer variables are used for dealing with integer data. We talked about Fortran constants, numeric constants, They are of two types: integer constants and real constants. So what are these integer constants or integer type of data? These are numeric data without a decimal point. For example, the number 123, 542, minus 63 without the decimal point. These are integer kind of data. So deal with this integer kind of data, we need integer variables. By default, in Fortran, all variables starting with letters I, J, K, L, M, and N are integer variables. Simply means, if I have a variable named I, it can store only integer data. So during the course of writing the program or compiling or running the program, let me say I have named a memory location as I, and if I supply a data with a decimal point and store it in this memory location named I, the data will be automatically converted into an integer kind of a data. Say I put a data 43.2, supply a data 43.2 and store it in the location named I. By default, I is an integer kind of a variable. So what will happen is that 0.2 will be lost. Only 43 will be stored. So this is something which we need to remember. All variables starting with letters I, J, K, L, M, and N are integer variables. I can have a variable named ink, INK. Just for example, I have named a memory location as INK. So that memory location can store only integer data. Whatever is stored there will be default converted into integer. Only the integer part will remain. The decimal part will be lost. Let me say I have something named a memory location as J1. That also will be an integer. So by default, they are integers. So variables can also be declared in the program name as integer variables. If I don't go for the default, let me say I want to name a variable memory location as, or a variable as sum, S-U-M, sum. This variable name does not start with any of these letters, I, J, K, L, M, N. So by default, it should be a real kind of a variable, S-U-M. But I want sum to be integer. So what I can do is I can declare sum to be an integer kind of a variable, overriding the default. So how do you declare? General format, integer list of variable. Integer, this is the declarative statement. Then the list of variables that you want to be integer kind of variables. So integer, I can declare area, age, IK. That simply means area is a variable which will store integer kind of data. Age, default it is not integer, but then overriding the default I am declaring it. While programming, when you write a program, it's always better to declare the variables using this kind of declarative statements. What happens in the process is that you exactly know what are the variables that you will be using. So this is integer variables. Real variables deal with real data. Similarly, so by default in Fortran, all variables starting with the letters A to H and O to Z are real variables. This is something again which you need to remember. If you don't want to use declarative statements like this, if you name any variable, it will take the default. So if I name a variable as ODD, odd, or anything like A1, A2, default they will be treated as real variables. Means which stores real data. Real data means numeric data in the real form, real constant that we talked about. Say 1.2 with a decimal point. This is a real kind of a data, or is a real constant. It has to be stored in a variable or a memory location which is real. Otherwise, as I said, what will happen, that 0.2 part will be lost. So variables can also be declared in the program as real variables, same as in the case of integers, overriding the default. General format again is real list of variables. Real is the declarative statement. So real sum, weight, am. So sum is a variable name, weight is a variable name, a and m, these are variable names which can store real data. Later when we actually write programs, these things will be more clearer than character variables. Again, character variables are used to deal with data in the form of characters. Character means in the form of alphabets. We talked about character constants, if you remember. I need to write a program where I need to ask for the names of people. So names of people can't be in the numeric form. That is obvious. So names will be in the form of alphabets. So this is character data that we are inputting. So this character data also needs to be stored. We can store it using character variables. So basically what you need to remember is variables, these are names of memory locations. So if I want to store character data, I have to name a memory location as a character variable. Character variables have no default and has to be explicitly declared. We are talking about integer and real data. Fortran has default for them. Any variable name starting from I, j, k, l, m, n are treated as integers. Otherwise, a to h and o to z, they are treated as real, as we have discussed. But characters, they don't have any default. We have to declare it explicitly. Character variable declaration also contains the length of the data it will store. So general format is character name star star 25. Name is the variable name, and star star 25 simply means the maximum length of the name that it will store can be 25 characters, 25 alphabets, not more than that. If it is more than that, the later only 25 alphabets will be stored, the others will be lost. So this is the general form in which we declare a character variable. So character is the declarative statement, name is the variable, and separated by comma we can have more, name star 25, so it can store a maximum length of a name 25 alphabets. We can have say any other C star star 5. So C also will be a character variable which can store maximum length 5, and so on. Logical and complex variables. So what are logical and complex variables? Logical variables are used to store logical data or values. We talked about logical constants. Logical constants can be of two types, true and false. Any logical evaluation, whether A is greater than B, it can be either true if it is greater or false, less. So logical value can be only of two types, true and false. So this logical data needs to be stored, if we want to store, can be stored in memory locations which are named accordingly. That means we need logical variables to store logical data. Declarative statement is this logical v1, v2. That means v1 and v2 are two variables which we have named and declared them to be logical. That means v1 and v2 can store logical data. Right. Variables which can store logical values which can only be two values, true or false. Complex variables are used to deal with complex data or complex numbers. We talked about complex constants. Fortran, as I said, has a limitation in the sense a complex number a plus of IB, I can't write it out exactly in the form A plus of IB. What I can do is I can store it as the real part of the complex number and the imaginary part. How we do that in a Fortran constant? It's called a pair, conjugate pair, within parentheses A comma B. That simply means A is the real part and B is the imaginary part. To store a complex number, we need complex variables. We need to name memory locations, and these memory locations, or the names of the variables, names of the memory locations, that is the variables, needs to be declared as complex. That means they can store complex data. So here declarative statement is complex AB. So here A and B will be variables which can store only complex data. Subscripted variables. So what are these subscripted variables? Subscript, all of us know, is a running variable. So these subscripted variables are variables with a subscript, as simple as that. Subscripted variables are used to store large amount of data. Large means say data going into thousands, 10,000, or even 4,000. Let me say the number of students in our college is around 4,000. So if I want to find out the average weight of all the students in Anthony's College, so what I need to do is I need to write a program which will ask for the weights of all the students. Now, to name variables, 4,000 variables, means I need 4,000 variables. Why? Because each weight that I supply needs to be stored in the memory location. First you input the data, all the data, then you ask the compiler to add it up. It will extract the data from the memory locations, then divide it by the number to get the average. So problem is dealing with large amount of data is becomes difficult to name, have different variable names for each data that we input. So what is the way around? We can have, or we can use a subscripted variables. We can have the same variable name with a subscript, right? So the declarative statement is something like this: dimension A, B, I, J, with I is the subscript, J is the subscript, and IJ here is the subscript. So in the case of the weights of the students that I was talking about, I can have a variable named W, which stands for the weight, with a subscript I. So the value of I will run from 1 to 4,000. So I can have W1, or for that matter here A1, A2, A3, A4, A5. These variables with subscripts are known as subscripted variables. These are very useful when we deal with matrices. If I have a 3 by 3 matrix, most of you have done in mathematics, the elements of the matrix can be A11, A12, A13, A21, 22, 23, A31, 32, 33. So we can use subscripted variables to deal with matrices. So A1 with one subscript, this is a one-dimensional variable. B1 subscript, it's a one-dimensional variable. Cij, it's a two-dimensional variable. We can have three-dimensional variables and so on. So these subscripted variables becomes very useful when we deal with large amount of data. Later when we go into the control statements, we'll learn more about this, how to deal with subscripted variables. Then, okay, just before going into library functions, another kind of variables that was listed is double precision variables. We'll talk more about it later, but just to mention here, double precision variables by default, a computer, a Fortran compiler, of course it depends upon the system that you are using and the version of Fortran that you are using, the maximum digits that can be stored is limited. So you can't store a number something like 1, 2, 3, 4, 5, 6, 7 dot 0.8953. It can't go on and on forever. There's a particular length. Some compilers, they allow 8 bits of the memory location. So the total length of the number can be 8 bits, some 12, some 16, depending upon the compiler, as I told you, and the system that you are using. Let me say I have a number which goes into 30 places after decimals. How to store it? You can have it in the exponential form, one way, or other way around. There is that option of what we are talking about, double precision variables. So if I name a memory location as double precision, what happens? That variable can store twice the length that the compiler usually allows. So if by default a system or a compiler allows 8 bits to be stored, if I declare a variable as double precision, it can store 16 bits. So to do accurate calculations, scientific calculations, sometimes we need more places after decimals for more accuracy. We can declare some variables to be double precision. So I'm just mentioning it here. Later we'll learn about it more. Now going into library functions. What are these library functions? These are certain mathematical functions that are allowed to be used in Fortran. These are also called built-in functions or intrinsic functions. So this is the list of library functions that are used in Fortran. One is sqrtx, where x is the argument, sqrt is the function. Within parentheses is the argument. Sqrt, it evaluates the square root of the function x. So if I want to evaluate the square root of 4, just have to write sqrt 4. It's self-explanatory actually, you can understand very easily. Exp, exponential of x, e to the power x. Log of x, this is log, natural logarithm with the base e. Log of x, x is the argument. Log 10x, log to the base 10. abs x, absolute x. So if I write abs within bracket minus 4, the value that will be returned will be 4, absolute. Sine, these are trigonometric functions. It evaluates the sine of x. It evaluates the cos of x. It evaluates the tan of x. A sine, sine inverse x, cos inverse x, sine hyperbolic x, cos hyperbolic x, and tan hyperbolic x. So these are basically the library functions that are used in Fortran 7.7 we are talking about. So you may be asked, what are the library functions? What are library functions? What are the types of what are the different library functions that are used in Fortran 7.7? And what is the mathematical operation they represent? So sqrt x simply represents square root of x. Expx, e to the power x. Log of x, mathematical operation also is log of x, and so on. So this is all I wanted to discuss in this video lecture. Next lecture will be going into Fortran statements and start writing simple programs. And once we start writing programs, all the things that we have learned till today, we'll put it into practice and you can understand more. But what we have been doing till now, discussing about algorithms, discussing about flowcharts, then we discussed about different Fortran constants, Fortran characters, then we have talked about Fortran variables, the library functions. Now we are equipped, well equipped with all the vocabulary, with all the alphabets rather, to write the Fortran language. That means to actually start writing Fortran programs. So till the next lecture, thank you.